Let's get started on your notes over rational exponents and radical expressions. So your notes might look slightly different than the ones I'm about to go through, but all the content is the same. So just follow along and fill in your notes. Let's get started. What do I mean by rational exponents? I mean exponents that are fractions. Okay, remember, a rational number is any number that can be written as a fraction. So a rational exponent is an exponent that's a fraction. So let's go into this little first part. Sometimes fractional exponents are used to represent powers of numbers or variables. The numerator of the fraction, m, represents the power. The denominator, n, represents the root. The exponent of the denominator must be positive. So if I look at my little rule over here, I have a variable that's raised to a power that's a fraction. That m represents the power and n represents the root. So if I rewrite it as a radical, remember a radical is any number or variable with this in it. Okay, so that symbol right there is a radical symbol. So when I rewrite these fractional exponents as radicals, I put the root right here, there's my root, and then the power goes right here. It's that variable raised to that power. But I could also write it like this, where the root is still right here, but that's all in parentheses, and the power is outside of the parentheses. So I just marked that up a lot, but I'm going to erase it. But I just want to point out that this can be written either way. I've got a little picture that we could use as a reminder that you're going to have your power over your root. Okay, as your exponent, your power is on top, your root is on bottom. So when I think of a tree, the roots of the tree are down here. They're below, they're on bottom. They're down here in the denominator. So power over root. Okay, let's get into our first example types. The first thing we're going to do with this lesson is just rewrite each exponent as a radical. So x to the power of 1/2, well, I'm going to write that as the square root of x. So x to the first power with a root of 2. Now remember, I don't really need this 2 here. You might remember in yesterday's lesson, I don't need that 2 there. It's assumed to have a 2 right there if I just have it look like that. And then I don't need an exponent that's a 1 because it's also assumed that it has an exponent of a 1. So this is my answer, the square root of x. Number 2, I can do the same thing. That's the square root of 9. Well, what is the square root of 9? It's 3, so we're just simplifying it. So anything to the power of 1/2, how can we rewrite it as a radical? We can just take the square root of it. On number 3, x to the power of 2 over 3, it's going to look like this. With a root of 3, x is going to be squared. But remember, I could also write it the cube root of x all raised to the power of 2. Either way works. So now in our next section, we're going to rewrite each radical expression as a rational exponent. Okay, so let's look at number 4. I've got the cube root of z squared. So I know I'm looking at z. That's going to be my base. And then power over root. Well, that the power is 2 and the root is 3. So z to the power of 2 over 3. Number 5. C is obviously my base. So I'm going to write a c there. The power is -5 over 3 is the root. And number 6, if I wanted to rewrite number 6 as an exponent, or with a rational exponent, well, if looking at number 1, if x to the power of 1/2 is the square root of x, then the square root of 6 is also, I could rewrite it like this, 6 to the power of 1 over 2. Power of 1, root of 2, power over root. Okay, in our next section here, it says all of your exponent rules apply to rational exponents as well. Simplify each expression using your exponent rules. So let's use what we know, that product rule, the power rule, the quotient rule, what we know about negative exponents. We're going to apply those all in today's lesson. So when we look at number 7, 4 to the power of 1/2, well, what does that mean? Well, if I rewrite it as a radical, it's the square root of 4. Well, what is the square root of 4? It's 2. That's a perfect square. Nice and simple. On number 8, if I rewrite it as a rational exponent, which is what I like students to do a lot, if you don't understand what you're looking at, rewrite it as a rational exponent and see if it makes sense then. So 2 to the power of power over root 6 over 3. Well, that fractional exponent I can actually simplify. That's 2 to the power of 2. What is 2 to the power of 2? It's 4. Let's look at number 9. The square root of x squared. Well, let's see. If I rewrite this right here that's inside my parentheses, I could write that as x to the power of, what would that be? 1 over 2, all raised to the power of 2. Well then, if I apply my power rule, let's see, what would that do? What's 1/2 times 2? It's just x to the power of 1, because 1/2 times 2, that's 2 over 2, which is 1, so it's just x. Well, what does that mean? That means that this radical and raised to the power of 2 cancel each other out. They're inverse operations. They undo each other. They cancel each other out. Okay, let's go on to number 10. 36 to the power of 1/2. Well, if I rewrite it as a radical, that's going to be the square root of 36. Oh, that's nice and simple. That's a perfect square. The square root of 36 is 6. Looking at number 11, okay, let's apply the power rule, because I have an exponent right outside of the parentheses, and that's what I'm looking at. That's what I notice when I use the power rule. I've got an exponent right outside the parentheses, so I've got to apply it into every single number and variable inside my parentheses. So that means 4 is going to be raised to the power of 1/2, and then x is going to be raised to the power of 1/2. Well, what do I do when I apply my power rule? I multiply my exponents. So 2 times 1/2, well, we just did that. It's 1. So 4 to the power of 1/2 times x to the power of 1. Okay, well, let's just kind of go through and simplify this. 4 to the power of 1/2. How can I rewrite that as a radical? The square root of 4. And then I'm just going to write it like this. Times x. I don't need that exponent of a 1 there, so I'm not going to write it. Well, what is the square root of 4? It's 2. So 2 times x, it's just 2x. Let's go on to number 12. Again, I have an exponent outside of my parentheses, so I know I'm going to apply the power rule again. Every number, every variable gets raised to the power of 4, okay? That means this coefficient here, 3, is going to get raised to the power of 4. That also means this variable with this exponent is going to get raised to the power of 4. What do I do with my exponents? I multiply them. That means 3 over 4 times 4 over 1, well, these can cancel out. That's just 3 over 1. So that's x to the power of 3. And if you struggle with multiplying fractions, you could always use your calculator if you're allowed. And 3 over 4 times 4, and it'll give you the answer of 3. And if it's ever a fraction, you could always do math, enter, enter. So 3 to the power of 4. What is 3 to the power of 4? That's 3 times 3 times 3 times 3, which is 81. 81 times x to the power of 3. Okay, let's go on to number 13, and they're getting more and more difficult, but let's just do it one step at a time. And you might see at the bottom of your page, it says remember to use your order of operations. That's PEMDAS, or please excuse my dear Aunt Sally. So we want to keep that in mind whenever we're simplifying these expressions. Okay, so on number 3, the first thing I notice number 13, the first thing I notice is that I have exponents outside of my parentheses. That means I'm going to apply the power rule, which means -4 is going to get raised to the power of 3, which is -4 times -4 times -4, which is -64. Remember your integer rules. So that's -64. Then x gets raised to the power of 3. So remember, we're applying our power rule, so we're going to multiply our exponents. 1 times 3 is 3. All right, moving on to the denominator, 49 to the power of 1/2. Well, I can think about this a number of ways. That is 49 to the power of 1/2 raised to the power of 2. Well, if I apply my power rule, 1/2 times 2 is 1. That's just 49. I could also think about it another way. 49 to the power of 1/2 is the square root of 49, which is 7, which I will then raise to the power of 2, which is 49. So either way you go about this, you're going to get 49 as your coefficient in your denominator. Then again, I'm going to look at this variable, and I'm going to raise x to the power of 2. That's x squared. So now I need to simplify this, and I look at my coefficients. I can't simplify -64 over 49 any more than it already is. However, I do have the variable x in my numerator and denominator, so I can apply my quotient rule. That's 3 minus 2, which is 1. So your answer is going to look like this. -64 times x, I don't have to write to the power of 1, over 49. All right, let's move on to number 14. Ooh, this looks a little scary, but don't let it scare you just yet. Okay, let's, I notice I've got this exponent right outside my parentheses, so I'm going to apply the power rule. So let's just rewrite it and see what we're looking at, because it does look a little scary right now. 64 raised to the power of 5 over 3. Times x to the power of, well, 3 over 1 times 5 over 3 is 5 over 1. So that's just going to be 5. Okay, so this is kind of difficult to understand. So I'm going to rewrite this as the cube root. Let's see if I can get that where it's not so. The cube root of 64 raised to the power of 5. Now I can write the 5 like this, where I'm raising 64 to the power of 5 and then I'm taking the cube root of that, or I could write it like this. And I'm going to write it like this because I know the cube root of 64. It's 4. So really, I could take the cube root of 64 and raise that to the power of 5. And then don't forget we have this times our x to the 5th times our x to the 5th. So 4 to the power of 5 is 4 times 4 times 4 times 4 times 4, which is 1,024 times x to the 5th. Let's move on to number 16. 15, I just keep getting my numbers wrong. Number 15. Okay, so again, this looks a little scary. I'm going to think about my order of operations. And the first thing I'm going to do is apply my power rule, since I have an exponent outside of my parentheses, to get rid of those parentheses. So 16 is going to get raised to the power of 1/2. And since I've done this, and this is my 15th example, I know that 16 to the power of 1/2 is just the square root of 16, which is 4. So 4 times x to the power of, what do I do with my exponents? I multiply them. 6 times 1/2 is 3 over. So now I've got 3 to the power of 3 over 2. I've got this exponent outside of my parentheses raised to the power of 2. Well, that means I'm going to multiply my exponent. So that's 3 over 2 times 2. And you could multiply across and then simplify. I like to what I call pre-simplify. So that's 3 over 1. Which is going to be 3 to the power of 3. 3 to the power of 3. We distributed that exponent, if you will, using our power rule. Then don't forget we have x to the power of 2. So now let's rewrite this. What is 3 cubed? Let's simplify a little bit at a time. And I'm actually going to change colors here just because I want to. 3 cubed, there's a couple things I'm going to be simplifying. I've got 4 over 3 cubed is 27. And then when I look at my variables, I have x's on top and on bottom. So I'm going to apply my quotient rule. 3 minus 2 is 1. So x to the power of 1 or just x. What do you think of that? This is fun. I love doing these. Okay, let's move on to the challenge. There's 3 problems that are challenging if these weren't already. But let's move on to the challenge problems. So number 13, oh my gosh, now I have a negative exponent. Okay, there's a couple different ways you can think about this. What I really like to do if I have that negative exponent, because negative exponents do not yield negative answers. They just mean we're dealing with very, very small numbers. So I'm actually going to rewrite this. 1 over 4x squared raised to the power of positive 5 over 2, if you can see that, to the positive power of 5 over 2. So now I'm dealing with positive exponents, and we just like that. It's just nicer. So everything is going to get raised to the power of 5 over 2. So I'm still in my denominator. Power over root. I'm actually going to rewrite this. 4 to the power of 5 over 2 is the same thing as the square root of 4 raised to the power of 5. Do I need this 2 here? No, it's assumed 2. Okay? But you know what? I do know the square root of 4 is 2, so I'm actually going to write it like this because it makes more sense to me because I know the square root of 4. So I'm going to rewrite this as the square root of 4 raised to the power of 5. So all I did was rewrite it so that it makes more sense. And then when I multiply these next exponents, 2 times 5 over 2, I get 10 over 2, which is 5. Okay, so a little bit at a time. So we are simplifying 1 over, let's do this first part right here, the square root of 4. What is the square root of 4? It's 2. So I'm going to be raising 2 to the power of 5 times x to the power of 5. What is 2 to the power of 5? 2 times 2 times 2 times 2 times 2. You can use a calculator to do that. You could also do that. Okay. Oh, looky there. 16. And I get 32. Either way, you do this enough and you're just going to remember 2 to the 5th power. 1 over 32 times x to the 5th. Aren't these fun? I love these. Okay, let's move on to number 14. Some of you are like, nope, this is not fun at all. I love it though. Okay, number 14. Oh my gosh, my head's hurting. Okay, so again, I'm going to apply the power rule because I have these exponents outside of my parentheses. So the first thing I'm going to do with this top number is I'm going to write it off to the side, that as a radical, because these fractional exponents sometimes are just very difficult to think about, but when we write them as radicals, they make more sense in our head. So that's the square root of 9. Oh, well, I know what that is. That's 3. Okay, well, I'm going to raise that to the power of 3. That's how I'm choosing to write this because I know the square root of 9. Okay, so I'm going to rewrite this numerator as the square root of 9 raised to the power of 3 times x to the power of, well, 2 times 3 over 2 is going to be 6 over 2. And if you want to write that down too, 2 over 1 times 3 over 2 is 3 over 1, which is 3. So we're raising that to the power of 3. And now in our denominator, okay, Okay, this is really confusing for a lot of students, okay? So this negative out in front right here with number 14, I want you to think about this as negative 1 times 3. Oh, I can't write that. It's kind of my pen is too thick. This is not, it doesn't look like this. I'm not raising negative 3 to the power of 1/2. I'm raising 3 to the power of 1/2. So I want you to think about this negative right here as a negative 1. So the first thing I'm going to do is raise that negative 1 to the power of 4, and that's positive 1. So in my denominator, I know it's going to be positive, and I don't need to write a positive there. I'm just writing it to let you know it's not going to be negative. So the first thing I'm going to do now is raise 3 to the power of 1/2 raised to the power of 4. So what do I do with my exponents? I multiply them. That's 1/2 times 4 over 1, which is 2 over 1. And I just pre-simplified. If you want to multiply across to get 4 over 2 and then simplify to 2 over 1, you absolutely can. So I'm going to get 3 to the power of positive 2 times x to the power of 2 times 4. I'm applying my power rule, and that's 8. Whew, does your head hurt yet? I'm going to change colors again just because. Okay, so we're going through and we're thinking about this. We're back in our numerator, the square root of 9 raised to the power of 3. Well, what is the square root of 9? Let's simplify that first. It's 3. So I'm raising 3 to the power of 3 times x cubed over 3 squared, which is 9, times x to the power of 8. Okay, so then let's keep going here. 3 to the power of 3, what is that? 3 to the power of 3, 3 times 3 times 3, that's going to be 27 times x to the power of 3. I just took that little dot away because you don't need it. I just write it there to kind of separate and make sense of it. Then 9 times x to the power of 8. Okay, so now we're just simplifying. 27 over 9, I got to simplify my coefficients first. 27 over 9 is 3 over 1. I don't need to write a 1 down there. I can. 3 over 1. And then if I simplify my variables with these exponents, I'm going to apply my quotient rule. 3 minus 8 is negative 5, which means that x to the power of positive 5 is going to be in my denominator. And you know what? I'm going to rewrite it. I'm going to write it. If I applied that quotient rule, it would look like this, to the power of negative 5. So again, if I have that negative exponent up here, I'm going to move it down here, and I'm going to make it positive, x to the power of positive 5. Whew, that was tough. Oh my gosh, we only have one more. Okay, longest video ever. Sorry about that, but these are good. I love these. So you can always pause this and try to do this yourself, but let's just kind of go through and see what we would do. So I'm gonna, let's see, I've got this radical, and again, if you see it as a rational exponent and you don't understand it, rewrite it as a radical, see if it makes sense. If you see it as a radical and it doesn't make sense, rewrite it as a rational exponent. So this right here, 16 to the power of 1, or I'm taking the cube root of that, I'm going to rewrite that as 16 to the power of 1 over 3 raised to the power of 3 over 2 times x to the power of 1/2. Okay, we're just going to leave that there. Okay, over 2 to the power of 5 over 3 times x, all raised to the power of 3. Okay, that's cool. Now I'm just going to apply my quotient rule. That means I'm going to be multiplying my exponents, 5 over 3 times 3 over 1. Okay, 1, 1, I get 5 over 1, which is 5. So 2 to the power of 5 times x to the power of 3 times x to the power of 1/2. Okay, Don't forget we applied our power rule to this x inside our parentheses, right? 1 times 3, so we got x to the power of 3. Okay, there's a couple things I'm noticing here. Let's just do one thing at a time. So I still have parentheses in my numerator, and I still have an exponent. I need to apply my power rule, which means I'm going to be multiplying 1 over 3 times 3 over 2 to get 1 over 2. Okay, so that's 16 to the power of 1 over 2. Okay, we'll just rewrite this. 1 over 2 times, well, what do you notice? I have the same thing, x to the power of 1/2 and x to the power of 1/2 in my numerator and my denominator. Those cancel, because when we divide them, we just get 1. It's not 0, it's 1. So I cancel them out. Okay, over 2 to the power of 5. Well, we did that earlier. Do you remember what it was? It's 32. Whoop. Times x to the power of 3. And some of you may remember that anything raised to the power of 1/2 just means we're taking the square root of it. So we're taking the square root of 16, which is 4. So 4 over 32x cubed. Okay, and now I've got numbers in my numerator and denominator. Can I simplify those? I sure can. 4 over 32 simplifies to 1 over 8. A lot of students, when they get that 1 in their numerator, they're like, what do I write there? Well, you need a placeholder. Write a 1. 1 over 8 times x to the power of 3. Oh my gosh, that was fun. Okay, I hope that helps. And this concludes your notes over rational exponents and radical expressions.